In this video, we're going to work on the interpolation between the idle pose and the aiming pose, as you can see here. So we'll have replicated aiming, and we're also going to work on some weapon sway, so the animations don't look so boring. Alright. So first thing we're going to do is we're going to fix a little mistake that I made last time. So this is what I originally wrote. If we are locally controlled, then we will immediately equip the weapon, and if not, and we are not the server, then call the server to equip. But what this ended up doing, I'll just show it really quick, is if I play like this, well, one sec. If I play with a client, you'll see on the other screen when we switch weapons, he's not actually seeing the weapons switching, because the problem with this code is that we are locally controlled, so it's running this, and this is an else, so then it's never actually sending it to the server to replicate that. And I believe if we played as a listen server it would work, but this isn't good. So what we need to do is, instead of this, let's just delete this really quick. What we need to do is, if we are locally controlled or we are the server, because we might want to call the equip ability or the equip function somewhere else, not locally, but if it's the server, then it will immediately equip, which is fine. And if we aren't the server, no matter if this runs, then we need to tell the server to equip the weapon, and with that, I believe that should work. And now, if I switch weapons, yep, you can see on both screens, you can see switching weapons. And that shotgun pose is really messed up, but that doesn't matter so much. And you can also see here that the spine bending in action. So I'm looking up and down, and you can see it's procedurally bending. And you see there's a bit of a hitchiness with the rifle, and we will fix that. That has to do with the update rate and there being no interpolation. We'll get to that in a bit. So first thing we're going to do is we're going to implement some logic in the control rig for the idle pose. But before that, well, actually, yeah, let's implement that first. So let's open the control rig. And in here, we're going to, instead of just running this, because this is for aiming, so this is the aiming code, we're going to add an interpolation. So interpolate, let's put this at the bottom. We're going to interpolate the aiming to not aiming values transforms by, let's promote this, and let's call this aiming weight. So when the aiming weight's at 0, I believe, it should not be aiming, and when it's at 1, we should be aiming. So just alone with that, I think we shouldn't be aiming anymore. Yeah, we're just doing some weird A pose. So we need to implement some logic for this node here. And let's expose the aiming weight, because we will want to change that. So in order to get the idle pose, what we'll need to do is, before we run any of this logic, we will want to set a few variables. Or probably just one variable. So we'll need a transform, and essentially we'll need the before we run any of the logic, when we're in the idle pose, which is the beginning of this, we'll need to get the head we'll need to get the head transform relative to the sights, so that when we look up, we can then run some logic and find the new transform that we should have relative to the new head rotation and transform. So let's create another variable. This one should not be public. Let's call it init head to sights transform. This is just going to be for internal use only, and we're going to set it here. And in order to get that, what we'll need to do is first, we're going to get the sights transform, which is the code that we have over here. So let's just copy this. Yeah, get sights transform. And this is going to be a relative transform, so make relative. Then we'll just plug this in for now. And then we'll need to get the camera transform. So essentially what that will be is it'll just be the head transform. So get transform head. And if we ever add an offset to the camera, we might want to add that. So let's just multiply transform. This isn't necessary if you have your camera at just completely no relative transform compared to the head. So, but we might want to add a bit of a location offset or something. So we'll just add a translation. So add, and you don't have to fill this out. Or not add, reroute. But we're not going to fill that out. And we might as well just add a visual debug. And with this, we don't actually want the rotation itself. We want to add the rotation afterwards. So we will just get the base rotation, which should be, let's just expand this. So we're going to put the translation in here. And for the rotation, it should be from rotator. And that'll be 90, I believe. And now that we've got the init head transform, let's just comment this. Now that we've got that, we want to get the transform that we made. So let's just get that. And we'll want to multiply that by the relative camera transform. So this is the relative camera transform is our actual transform. So this transform down here is essentially us looking straight ahead, and that's what the base pose imitates. When we're in our base pose, that's the transform that we should have just looking straight ahead, and that's the pose that we should have. But now we need to offset that. So we multiply those, and that should get us our new relative camera transform. So that should be it should basically be what the base pose looks like, but attached to the head essentially. You'll see what I mean. So let's just plug that in. Non-aiming. And let's see if that worked. Alright, look at that. Now we've got our idle transform, and you'll see that it's always in the idle pose, just relative to the camera, and we're not getting any of that weird latency. Like if I just plug it in like this, and just disregarding this weapon space pin, then you'll see it looks a bit strange without the inverse kinematics and has a bit of shakiness. So when we plug this in, now it's completely stationary, so that's good. Also, one other thing we should probably fix soon is, you see how when I'm turning really fast, you can actually see the inside of my head. We need to fix that as well. So let's actually just fix that now. That's relatively quick. So go into your character and let's add another component. Let's see where our components are. Let's go down here, view property. We're going to make a skeletal mesh. And this will be our client mesh. So essentially, what we're going to do with this is the client mesh will have the exact same pose every tick as our mesh that we're using, and only on the client our standard mesh will be invisible, but it'll still be casting a shadow, so when you look down you'll be able to see the shadow, and you'll see that we still have a head, or at least it looks like that, but the client mesh will be the exact same mesh, but we'll make the head invisible. So when you look down at your body, you'll see your body and everything, but you won't be able to see the inside of your head. So let's create that component. And for the client mesh, what we're going to need to do is we're going to need to set cast shadow, and it should not cast a shadow. We only want our mesh to cast a shadow. And let's just set this to false. I'm not sure if this is entirely necessary. What is it? B. So basically, if we create like a mirror or something, we won't be able to see our client mesh. We'll only see this mesh. And we'll also need to set its ticking group to the same tick group. So we don't get any latency. And we'll set up the attachment. And we'll want to attach it to our mesh. And for the mesh, we'll also need to add a few more things here. So set this to true. So even when our mesh is invisible, because we will set it invisible, it will still cast a shadow, and we will see it in reflections, and we won't see the client mesh. The client mesh will copy the pose of our primary mesh, but it'll just not have a head. And in order to do that, we'll need to, on begin play, let's add a little bit of logic. If we are locally controlled, so if we are locally controlled, we're going to get the client mesh, and we're going to hide the head bone. Let's actually hide the neck too. It'll propagate to the head as well. So hide your neck, and if is none. Doesn't matter. What's the error here? Oh, hide bone by name. Let's do like that. And we'll set our mesh to invisible. But if we aren't locally controlled, we have no need for this client mesh and we don't need it to waste resources, so we'll just destroy it. Alright, so you won't actually want to reference this if we're not locally controlled. Alright, now we're going to go into our character. Let's see if it's actually been made. Yep. So set the client mesh. What we're going to do is just set it to the exact same mesh as our character, which is mannequin in this case, and we're going to want to create a animation blueprint. This one will be really brief. So mannequin client mesh. And there's a node in here. I believe it's copy mesh, copy pose from mesh. So we'll have to get a reference to our mesh, and in the event graph, let's just do what we did in C++. Essentially, we'll just keep casting to the character until we get it, and we'll create a variable here. Let's just call it mesh. Skeletal mesh component, object reference. And another one, character. Get character. If it's not valid, then we're going to cast to the character. And when that is valid, then we'll set the mesh reference. And now that we've got the mesh reference, we'll just plug that in here. And I believe with that, if we go into here and we apply that blueprint, it should copy. Yep. Alright, let's see if that worked. So let's just play standalone for now, so you can see this. Well, okay, the client mesh is clearly working, but it kind of broke our animations, so that's interesting. Okay, so we need to update the blueprint because it actually hasn't updated the cast hidden shadow reference, or cast hidden shadow. So compile, let's see if that works now. Yep, alright, it works. So now we can move our head as fast as we want, and we aren't actually looking inside of our head anymore. And you'll see in the shadow, you could see that we have a head, but if I zoom out of here, we actually don't. And in reflections, we should just see our base mesh. Alright, that's looking good. Alright, so in order to make our animations look a whole lot less boring, because this is just completely static, what we will do is let's add a little bit of logic to our control rig really quick. So in here, after we interpolate, we're actually going to want to add an offset, if we have one, of course. Let's just move all of this. It's actually just, everything's kind of getting in the way, so. So from here, we're going to want to multiply, and this will go at the bottom. Let's plug that back in. And we're going to want to promote this to a variable, and this will be public, and this will be our offset transform. So whatever weapon sway or weapon bob or whatever we want, this that will be added to our offset transform, and we'll tweak that later. And another thing we can add over here for not aiming, let's multiply again. This will go at the bottom. And let's plug that in here. Let's promote this to a variable. And this will be our custom weapon offset transform. And this is one of those IK properties that I told you to set up previously. And this will offset our base pose when we're not aiming. And in our here, in our true FPS in the anim graph, let's just expose all of those. So now we're going to need to implement those. So aiming weight, we'll do that first for actual aiming logic. So in our anim instance, what we're going to want to do is we're going to want to expose a variable of a float. And let's call it float ADS weight. Let's just set this to 0 at first. And this will be our interpolation between aiming and not aiming. 0 being our idle and 1 being aiming. And we're going to want to smoothly interpolate, and we'll do that in the character. So we're actually going to want to reintroduce our tick. So just set this to true, and let's create a tick. And we're going to want to have a few functions. So let's see. I'm just going to create a new section here. Let's make it public. And let's make a function. Let's give it the category of animation, just because that seems fitting. And we're going to call this aim. Start aiming. Let's call it that. And we're going to have another function. And we'll call it reverse aiming. And in order for this to work, we're also going to want to replicate these to the server. So let's just add a protected section here. And we're going to have server RPCs, make them reliable. Let's call it server start aiming. And the same for the reverse. And we're also going to need a variable here. So let's create a variable, uProperty, edit anywhere. Sure, whatever. Let's put blueprint read only. Let's give it the category of, this is going to be in configurations, and let's give it a subcategory of anim. And this will be our curve float. So uCurve float. And this will essentially be our timeline for the aiming. And let's just call this aiming curve. And we're going to want to create a timeline. So I believe it's timeline, F timeline. Yep, you want to include that. And let's call it aiming timeline. And in order to set this up, I think we do it in begin play. Alright, so in begin play, first I'm just going to add a few comments so we can separate this out. So this is for our client mesh logic, and over here this is spawning weapons, and above that let's just do our setup ADS timeline. So we're going to need a let's see, F timeline, timeline float, F on timeline float, and we'll just call this timeline float. And our timeline float, we want to bind dynamic, and we're going to want to create a function, and this will be essentially our progress, our aiming progress. And you know, I can actually clean this up a bit, we'll do that in a second, but down here you're going to want to mark it as a U function, and this will be our timeline progress, and I believe it takes in just a float, and this will be our progress, or let's call it value, so timeline progress. And instead of the server start aiming, stop aiming, because that's a lot, let's just do U function server reliable and void server aim, and we can just pass in a bool and say be forward. Just set it to true. And essentially if we're aiming forward, like we're starting aiming, then this should be true, and if we want to reverse, then the opposite. So and we're also going to need a net multicast. We want to net multicast to everybody. Net multicast reliable. We'll call it multi aim. Pass it in. Alright, we'll implement those in a bit. And we're also going to need to create a variable here. And this will be, well, up here actually, it needs to be public. So this is going to be the important bit. This is our actual aiming value. So it's going to be blueprint, well, let's see, edit anywhere, blueprint read write. This will be a float, and this will be our ADS weight. Set it to 0, and we're actually going to want to set this to replicated, and you'll see why in a bit. We don't actually want to replicate it every single tick, obviously, because that's going to be very wasteful, sending a whole bunch of replications. So we're going to implement another function in a sec that'll make it so it only replicates once the timeline's complete, just so everybody's in sync, no matter if the multicast worked or not. Like if they joined the game afterwards, you'll still look like you're aiming on your screen, even if they didn't receive the multicast. So we're going to want to bind the timeline float to our function that we created. So a true FPS character timeline progress. And now for our timeline, aiming timeline, we want to add interp float, and it's going to be the timeline float. Is that it? We also need to implement the curve. So let's only run this logic here. Let's add an if statement. If what is it? Aiming curve. So if we have an aiming curve, then we'll run this. Otherwise, will crash, and that's not good. So let's put the aiming curve in here. And all right, now that we've got that, in our tick, we need to do timeline, aiming timeline, tick timeline, and implement the delta time. And this will make it so that the track will actually run. And now let's implement our function for the timeline progress. So void a timeline progress. And for the timeline progress, we're just gonna set the value to our ADS weight, simply. ADS weight equals value. I believe that's all we need to do. And for the server set aim, we can just implement this in line. And all it'll do is it will call the multi-aim and its implementation. So multi-aim, this will be the actual RPC, pass and B forward. And it'll also run its implementation, so it'll run locally as well, because the net multicast won't run on the server by default, so you need to actually call the implementation. And the multi-aim is where our actual aiming logic will run. But before that, let's implement the other functions above. So start aiming, just implement all of them. Reverse aiming, and multi-aiming implementation. So we're essentially going to run similar code to the equipped weapon. We want to run the logic if we're the server or if we're locally controlled, and if we don't have authority, then we want to RPC the logic to the server. So we'll write it similarly. So if is locally controlled or has authority, and we want another if statement if we do not have authority. So in here, all we'll do is we'll run multi-aim implementation and make this true because we are aiming forward, we are starting it, and if we don't have authority, then we want to call server aim and pass in true. And what this will do is this will make a round trip to the server. If we aren't the server for the client, this will RPC to the server, tell it to run the function on the server to aim, and then it'll also multicast that to every other client. And we want to implement it the exact same way here, except to make these all false. And now in here, what we're going to do is we're just going to get the timeline, aiming timeline, and let's have an if statement for if be forward, else. In here, aiming timeline, play, just play, and this should play forward, else aiming timeline, reverse. Alright, that's simple enough. And now that we have that function set up, what we should do is we actually need to have an input bound to aiming and not aiming. So let's create a binding. First of all, we need to go into input. So project settings, input, and let's have an action mapping, and let's call this aim. Set it to right click, and let's do this. And when we press it, we want to start aiming. Not begin play. Start aiming. And when we release the aim, we want to stop aiming. All right. And nothing's gonna happen because we don't actually have a curve. So what we need to do is, let's just make it here. Go to miscellaneous, miscellaneous, curve, make it a curve float, and curve float, let's call it aiming curve. And so you can set this up however you want. Add a key, it's shift right click, and at first it should be at 0, 0, and the value should be 1. Oh, that's the time. Value should be 1. Sure, let's just make it go over, let's make it go over 2 seconds so we can really see it. And if we go like this, and you click cubic interpolation, or yeah, then you can actually add a little bit of a curve to it like this, so you can smooth it in and out. Let's make it even smoother. So yeah, there we go. Something like that. Save. Go into the character, and if it compiled correctly, we should, in our configurations, have an anim slot. Yep, and we can implement that aiming curve. And let's see if that worked. Well, well, of course it wouldn't work because we haven't actually plugged in our ADS weight into our control rig. So in our anim instance, let's create a variable. Oh, we have already got it, ADS weight. So in our set variables, let's just always, every tick, set that to our character's ADS weight. So ADS weight equals character ADS weight. And that should be good enough in there. And we just need to plug it in now. Alright, let's see if that worked. Aha, look at that. So I right click, we start aiming, and you see how smooth that is, and I release and we stop aiming over the timeline. And we're going to implement our own weapon sway, so unless you want to use your own sway animation like this, which is fine, but in this case I want to procedurally make my own. So what I'm gonna do is in here, let's get the current pose I'm using. Let's just delete this, I made this earlier. So in this rifle iron sights idle pose, and by the way, this is from the animation starter pack in the Unreal Marketplace. It's free, you can just download that. Let's just pause this. I'm gonna get this one frame, and let's just make this our static pose. So create asset, create animation, current pose, and I'm gonna call it idle rifle iron sights pose. Let's put that in here. And inside of here, let's just delete this. and compile. Now I'm not getting any of that, and you can see how smooth it is. And I also did in the rifle, if we go to BP rifle, I also did in the IK property set this to 30, which is way too high for our aim offset. So let's set that to 18 or something. Alright, looking good. And in here, let's see if I set this up yet. So our custom weapon offset, we've already got a custom weapon offset for our IK property, so let's just plug that in. And it shouldn't change anything because I haven't set it up, but just note this position of the rifle and let's see if it actually worked. So let's go to the custom offset and let's reduce the location. Let's make it really close to us, so -10. And you see that it actually did work. Now our weapon is much closer to us. And when I'm aiming, it just, no matter what, still goes back to that position. So our custom offset has nothing to do with that. And I could even just give it some silly value. Let's just give it a roll. I believe this is roll 20. Oh. Alright, and when I aim, it's going to return to the aim position no matter what. So you can tweak around with that, and no matter what, your aiming will still function as normal. And so now we need to work on the actual aim offset, the offset transform. And this transform is going to be really important. That's where we're going to implement all of our weapon sway. So in our anim instance, let's implement another transform. And call it offset transform. Also, before that, I want to just make sure that this actually is being replicated. So let's just set it up, client, and set up 2 characters. So on their screen, let's see if it worked. Yep, it's being replicated. So everything's working properly. Also, one other thing that I just realized I forgot to implement was I did set that property to replicate it. It's obviously not replicating right now, but this is just a kind of an assurance policy to have the ADS weight be replicated, because it will maintain state. So that means if I'm fully aiming the way that we're going to set it up, and you join while I'm aiming, so you didn't receive the net multicast, if I didn't set this to replicated, you wouldn't see me aiming, even though I am aiming on my screen. But if we set this to replicated and only have it replicate if the value is 0 or 1, then when I'm fully aiming, you'll see it no matter what. But if we replicate the entire interpolation, having a bunch of replication values, that's just going to be a waste. So we're going to have to implement another function up here. Virtual pre-replication. Yep. And let's put that below get lifetime replicated props. Call the super function. And before that, we need to set it to replicate in the first place. So set lifetime. I keep using condition, but we're not actually putting a condition in there, but it doesn't hurt. So ADS weight, condition none. So now it's being replicated, and we want to just make sure that it only replicates if the value equals 0 or 1. So for fully aiming or completely idle. So do rep lifetime active override, and I'm gonna pass in our character class and the parameter, and over here this will be a bool value that'll basically tell us if it's true, then we should replicate. If it's false, then we shouldn't replicate. So it's going to be if ADS weight is greater than or equal to 1, or ADS weight is less than or equal to 0. And that should make it so it only replicates if the values are 1 or 0, essentially, because it should only range between 1 and 0. Let's compile. And it might not work off the bat because replication's kind of weird with the hot reload. But you won't see it anyways. This is just an assurance policy anyways. It's only for people that join the game later really far away and they didn't receive the multicast anyways. But it should all still work the same. Yep, still seeing it, of course. And it works for the shotgun as well. It's really messed up though. Yeah. Alright, now let's start implementing some weapon sway. So in order to do that, we're going to go to our anim instance, and it should be in this calculate weapon sway. So the first thing, so in this calculate weapon sway, first thing we're going to do is we're going to set up two variables, vector, let's say location offset, and you want to initialize it to 0 vector. I don't know why, but this prevented a weird glitch. I think it's more for the rotator, so also rotator, rotation offset, and make that a rotator, 0 rotator. Because sometimes the rotator, when I began the game, it was like negative 89.999, and it really messed things up, but this fixed it. So for every single bit of offset we want to add, we're just going to do location offset plus equals whatever our offset is. And so that means we can keep having additives, and then we'll eventually at the very end of this, just down here, we're going to do offset transform equals the transform of the rotation offset and the location offset. And we're going to have a bunch of logic in the middle here. So the first thing I want to implement is a rotation, like an accumulative rotation offset. So basically, when I'm looking around really fast, or not even necessarily, like when I'm looking, the weapon should have a little lag. It should kind of drift in the opposite direction of where I'm looking over time. So let's implement that first. And we're going to have a bunch of accumulative offsets. So let's just create a whole section for that. We're going to call this accumulative offsets. And just have one right here. U property. Not sure if it's necessary to have it be a U property unless you want to edit it. But I'll just do it anyways. Yeah, anim, and we'll call this accumulative rotation. Whoops, should be a F rotator, accumulative rotation. And in order to get the accumulative rotation, I'm gonna add another section here. Let's just call this state. This will just have a bunch of generic values that we'll need, and we're going to need the old rotation value. So U property last rotation, so we can get the difference each time. And at the very end, even down here, it shouldn't even be in set variables. We should just make last rotation equals, let's just make it the camera transform, get rotator. So in order to get the accumulative rotation, we're basically going to want to keep adding the offset onto the accumulative rotation, and we're also going to want to decrement it down back to a 0 rotator over time. So when we're not looking around, it's going to eventually return back to our rotation. So let's see. Let's get the additional rotation. It's going to be add rotation, and that's going to be our camera transform rotator, and minus our last rotation. So this is the difference, and let's just add a section here. Let's just call this accumulative rotation. And you know, we should probably put this into the set variables. And from that, we're also going to want to add a clamp. So let's just set that up here, angle clamp, and I think 6 is a good value. So essentially, for spinning really fast, we don't want to be able to go over a certain value, because if we just added 100, then the weapon would go flying off the screen, and we don't want that. We want it to be slow, so we want to clamp it at 6. And we're going to need to, from this add rotation, we're going to need a clamped version of that. So f rotator, add rotation clamped. And that'll be set to a rotator, and use fmath clamp angle, and this is going to get kind of lengthy. So for the pitch, it's just going to be the pitch, but we're going to have to clamp it. So add rotation pitch, so clamped in between the negative and positive angle clamp values. And for the pitch, actually, I think it looks nice to add a little bit of a multiplier, because we want the pitch value to change a bit more, because you don't look up very often. And for the yaw value, we're going to do the same thing, fmath clamp angle, add rotation dot yaw. And we don't need to implement the yaw or the roll, because our camera will never have a roll value anyways. Actually, so I think it looks nice for when we're looking horizontally to add a bit of pitch to that, so the weapon's kind of tilting into it. So what we're going to do is we're going to get our add rotation clamped, and we're going to set the roll out here, and we're going to set that to our add rotation dot yaw, because this is when we're looking clamped, when we're looking horizontally, and we're going to minimize that. We're going to make it 70% of the yaw value. And then for our cumulative rotation, we're going to offset it by our add rotation clamped. And our cumulative rotation, over time, we also need to set it back to our base rotation. So over time, what we're going to do is we're going to do ukismet math library, include that, and our interp2. So this will basically interpolate back to a value over time. So current is going to be a cumulative rotation, just like that, and our target is 0, so 0 vector, 0 rotator. You're going to want to put in delta time, and we may make this a separate value, but we want to give it a certain interpolation speed. the return speed, but for now I'm going to just set that to 30. And you can set that to whatever you want. You could expose that as a variable if you want. So essentially this accumulative rotation, we're not going to directly plug that in into our offset. This is essentially our target, but it's changing instantaneously and it'll look really strange if you put that onto a weapon. So we're going to need another variable right below. And this will be an F rotator, and this will be accumulative rotation interp. And what this will do is it's going to try and catch up to the target by interpolating towards it, and this is the actual value that we'll use for our offset. So right below, accumulative rotation interp, and it should equal, it should interp to, just like we're doing here, but this is to return, and this is the target value, and this is trying to catch up to it at all times. So that means we get a little bit of delay, which is what we want. We want it to smoothly interpolate, and we'll set that to the current value is itself. Its target is this delta time, and our interp speed, let's see, 5 is a good value for this, but you can expose this as well. And with that, let's just implement this first. So for our offset rotation, or rotation offset plus equals, we're actually going to need to inverse the rotation because it's going in the direction of our camera, and the problem with that is we want it to be lagging behind, so it actually needs to be the inverse of that. So we're going to create a rotator, and we're going to call it accumulative rotation interp inverse. It's getting pretty long. And set that to the accumulative rotation interp and inverse that, get the inverse, and we'll add it to that. And the reason we want to actually save this is because we're actually going to add it to the location as well. So when we're turning, we actually want the location to lag behind as well. So location offset plus equals, and we're going to make a vector, the x value forward and back, that shouldn't change, and we're going to, from the yaw value of it, accumulative interp rotation inverse, the yaw value will go directly into the y value, so horizontal, and we'll put the pitch value into the z pitch. Alright, and these values will be too large on their own, so we'll divide the whole vector by 6. And now let's compile and let's see if it looks decent. Oh, right, we actually need to plug in the offset value into the control rig. So let's go into the character, offset transform, get offset transform. Now let's test that. And look at that. We've got a bit of interpolation, so when I'm turning, you can see the weapon turns with me. And yeah, it's looking great. And it's all additive, so as you see, and it's based off of the iron sights location, so no matter the orientation of the sights, it should always be relative to that. So when the weapon's pointing forward, it's not turning at a strange angle or anything, it's still all centered, and it's all additive. So when I'm turning around, it's so with this you can also add other logic, like what we're going to implement later is probably a weapon weight. As you can see, this is feeling pretty sluggish. You probably don't want most weapons to have this much delay, and what you can do is you can multiply all the offsets by your weapon weight scale, and that'll actually set how much delay you want on your weapons. In fact, we could just do that right now. So down here, right before the offset transform, all this logic's run, we're going to get the location offset, multiply that equal to our IK properties, and okay, we didn't set up a weight scale, so let's just do that really quick. So let's go to the weapon, and let's just add another section here. I'm just gonna move this. I think it looks better down here, and edit anywhere blueprint, and let's call this weight scale, and by the default this should be 1. This is just gonna essentially be just the weight that you saw there. And location offset, we're gonna multiply that to the IK properties weight scale. So that means if the weight scale was half, it would half this location offset, and it would look a lot less sluggish. And we're going to do that with the rotator as well, but you can't directly multiply rotator, so we're going to have to do that with every single float value. So get the pitch. Let's just copy this. And with that, now the weight scale should be applied. And if we make the weapon lighter, then it should be more responsive. And if we make it 0, then essentially none of this will even run. It'll just null everything, and it'll just be stationary. So let's check our weapon. Well, first, let's just make sure I didn't break anything. Yep. Oh, and it also reset our relative transform placement thing. So it's looking like that. A lot of latency. And if we go back here and I set the weight scale to 0.2, so it's really light, you'll see it's much more responsive. It's much more centered in our screen. And when we're aiming, yep. And you can also set a custom weight scale, so like if I'm aiming, you want it to be more responsive anyways, you can have it while you're aiming. And if I want it to be extremely heavy, let's just set it to 3. This is going to be a really stupid value. You'll see, yeah, you don't, unless you're making like a meme game, you probably don't want it to look like this. But alright, well, that's all for this video, and in the next one, we'll implement some more weapon offsets, like movement offsets, so when I'm moving left and right, it should have a little bit of a delay. You could probably find a way to implement those yourselves if you want to try that. That's a bit of a challenge. And yeah. Alright, that's all for this video. So we implemented a bit of weapon sway, and in the next video we'll probably implement some movement sway. So when I'm moving left and right, the weapon will have a little bit of a sway as well. And when I'm jumping, well, we haven't even implemented jumping at all yet, and we may get to the lower body and maybe some lower body IKs for foot placement. And maybe we'll eventually fix the shotgun one day, who knows. And maybe recoil.